In this video, we're going to talk about the limits of trig functions, and in order to do that, we're going to take a look at 3 different examples of trig functions. Before we do that though, let's actually take a step back because we're actually a little more familiar with rational functions. So for instance, if I had f of x equals x minus 2 over x minus 4 times x minus 2, the graph would look kind of like this. And remember that these rational functions have vertical asymptotes and horizontal asymptotes. This one has a vertical asymptote at x equals 4, which is coming from this factor in the denominator. We also have this x minus 2 in the denominator, but remember that's going to cancel with this other factor on top, and that would create a hole in the graph. And actually, if I drag this point over here where x equals 2, you can see that the point just completely disappears because the graph is undefined there. And the graph is also undefined where x equals 4, but in a very different way. Right here it's because we have a vertical asymptote. And so when we're talking about limits, it's just a way for us to extend our thinking about functions and their graphs. So we're used to saying things like when x equals 5, like this function equals 1. You can see on the graph we have this point 5 comma 1, and that's evaluating a function. But sometimes we can't evaluate a function. Like this one, we can't evaluate at x equals 4 because there's a vertical asymptote there. But we still want to be able to talk about that point, x equals 4, on the graph. So instead of talking about evaluating it, figuring out what the actual value is, we talk about the limit instead. So you can see if I drag this point around, if I'm approaching that vertical asymptote at 4, if I'm approaching that from the right, you can see that the point is going up really fast. So we would say that the limit of the function as x approaches 4 from the right is positive infinity, right? The limit of the function is positive infinity because that's where it's going to. It'll never actually reach positive infinity, like that's not a destination you can get to, but it'll get closer and closer to it. So we'll say the limit is positive infinity. On the left side, it's different though. If I approach x equals 4, the same value, but if I approach it from the left side, then the point's actually going down towards negative infinity. So we would say the limit of f of x as x approaches 4 from the left is negative infinity. Now, because it approached positive infinity from the right, and because the limit was negative infinity from the left, we actually say
the limit does not exist. The limit does not exist!
Like you can't have two values that are more different from positive infinity and negative infinity. So the fact that they are approaching different values from different sides, that means that the limit can't exist. We can't nail it down and just say it's one single value. So that's the basic idea we're going to use, but now let's take a look at trig functions. So example 1 says we have to start with the graph y equals 2 times tangent of x minus pi over 4. So this is going to move the graph right pi over 4, and I remember that tangent has a 0, 0 value, like the first tangent value is 0. So if I'm moving that right pi over 4, I'm just going to put that middle point right here at pi over 4. And this graph was already labeled for us, so we have to use what's given here. Now remember that that 0 point is right in the middle of the two vertical asymptotes, and tangent has a period of pi. So that means I need to go like a half a pi in each direction before I draw my vertical asymptotes. So on this graph, pi over 2, or a half a pi, is like this distance, so I need to go that far, so like 2 main grid lines. I need to go that far to the right, putting the vertical asymptote at 3 pi over 4, and then to the left, if I go 2 main grid lines, that would bring me to negative pi over 4. And just to double check, if you took 3 pi over 4, this distance, and added 1 pi over 4, that would get you 4 pi over 4, that's 1 full pi, so the period is pi, just like we want it to be. And this graph has also been vertically stretched by 2, which just means it's going to grow up faster towards each vertical asymptote. So normally between this 0 point and the vertical asymptote, normally the next point is over at 1, and this graph has the y-axis going up by 1s, so that'd just be 1 grid line. So normally the point would be right there, but this one is stretched by 2, so it's actually going to be at 2 units tall. And then over to the left, it's going to go 2 units down. So this is the basic shape of the graph, and then we'll just continue that pattern to the right. And from this vertical asymptote, if I went pi units to the left, that would bring me off the graph. So I just know that the middle point, like the 0 point, is going to be right here at negative 3 pi over 4. Again, just looking at the same spacing here and here. And then it'll be increasing towards this vertical asymptote. And now that we have a graph to look at, we can answer these questions. So this says, what is the limit of f of x? So we're assuming that this was supposed to be f of x here. That's our function. What is the limit of the function as x approaches pi over 2? Well, let's see what's happening at pi over 2. When x is pi over 2, the graph actually just has a value there, and it's a good thing that we graphed it accurately because that's one of the points we were looking for. So the value of the graph is exactly 2. So this is kind of a weird question to ask because there's nothing weird about that point. Like we could just say f of pi over 2 equals 2. But this next one gets a little trickier. Okay, so this one says what is the limit of f of x as x approaches 3 pi over 4, and this little plus sign here, that notation means from the positive side, or from the right. It's easy to get mixed up and think that this is just a weird way of writing positive 3 pi over 4, but that's not the case. If we wanted it to be positive or negative, like 3 pi over 4 is positive. If we wanted it to be negative, we would just put a negative in front. Okay, so this means the direction that we're coming from. So we have to look at the graph where x is 3 pi over 4, but we want to see what's happening as the graph is approaching it from the right. So from this side, if you follow the graph towards that x value of 3 pi over 4, the graph is actually going straight down. It's going to follow that vertical asymptote down towards negative infinity. So that's what we'll say. We'll say the limit of f of x is negative infinity. And this example looks almost exactly the same, but this one's saying come from the negative side or from the left. So we're still approaching positive 3 pi over 4. It's not negative, but we are coming from the left side. So again, this is where 3 pi over 4 is, but we want the graph to be approaching it from the left side. So if I start on the left side of that vertical asymptote and follow the graph towards 3 pi over 4, the graph is growing up towards positive infinity. And it's these two results that give us the answer to this question. Because this one's saying what is the limit of the function as x approaches 3 pi over 4, but it doesn't tell you what direction to go from. Since we don't know the direction we're going from, I can't tell you what the answer is because depending on the direction you approach it from, you get totally different answers. So one could say,
The limit does not exist. The limit does not exist.
and that's usually abbreviated with DNE. Basically, it's a similar result to when you're trying to solve an equation and you get to the end of it and you find out that there's no solution. It's kind of like that. So let's take a look at another example. This one has us looking at y equals 2 times the secant of x minus pi. So to save some time, I'm not going to walk you through graphing cosine and secant. I'll just graph it quick and then you can copy it down. So the cosine is in red and secant is the purple graph. And just like on the last slide, we start with a pretty easy question because it says what is the limit of the function, which we're talking about the secant function in purple. What is the limit of the function as x approaches 0? So we'll take a look at the graph where x equals 0, which is right here, and the graph is down at negative 2. So there's a nice point there. Even though we can evaluate it, we could also say, it's a little bit redundant, but we could say that the limit is negative 2. But again, these are a bit trickier. So this one says what is the limit of the function as x approaches pi over 2. Again, that plus sign means from the right. So if I look at where x equals pi over 2, I can see there's a vertical asymptote here, and that's what's making this question trickier. So it's saying follow the graph from the right. So I'll start over here a little bit and follow the graph towards that x value of pi over 2. So it's approaching this vertical asymptote is going up towards positive infinity. However, from the left, this graph is approaching negative infinity because it's going down following this vertical asymptote. So approaching this x value from one side gives you a limit of positive infinity. Approaching it from the other side gives you a limit of negative infinity. Again, these are completely opposite values, so we can't say what the limit actually is if we don't specify what side we're coming from. So when it just says x is approaching pi over 2, we would have to say that
The limit does not exist.
So just one more example. This one is having us take a look at cosecant. So again, I put sine in red and cosecant in purple. So the first question asks, what is the limit of f of x as x approaches 3 pi over 4? And it doesn't specify what side we're coming from, but 3 pi over 4 is right here, and if we follow that up to the cosecant, there is some value there. But I didn't do a great job of graphing this part of the graph, like I didn't plot a point, so I'm not exactly sure what the y value is, so it'd be a good idea to plug 3 pi over 4 into the function. And that'll tell me what the output of the y value is. So 3 pi over 4 minus pi over 2 would be pi over 4. Like if you think of one full circle and you've got 3/4 of it, and then you take away half of it, that would be this much. So then you're left with just a quarter. So this is saying 3 times the cosecant of pi over 4. And if I want to figure out what that is, I've just got to figure out where that is on the unit circle. So pi over 4 is here, and so the legs are the same. It'd be like square root of 2 over 2, square root of 2 over 2. The sine value is just the y value, that's square root of 2 over 2. And the cosecant is the reciprocal of that. So this would be 3 times, cosecant would be 2 over square root of 2. So that would just be 6 over the square root of 2. And if you want to know what that is roughly just as a decimal, just plug it into a calculator, and you get about 4.24. Since this is all just really pure math though, I'm going to answer with the exact value, 6 over square root of 2. This isn't like an application where decimals make more sense. So I'll just write 6 over the square root of 2. That's the limit. It's nice to do this just to verify it, and if you look at the graph, it's around 4, so yeah, that makes sense. Now these next questions, they look like they're going to be tricky because we're back to that thinking where we're saying x is approaching pi over 4 from the right side, or here is from the left side. But when we look at the graph at 5 pi over 4, there's just a value there. And it actually doesn't matter if you approach that value from the left side or if you approach it from the right side, the graph hits the same exact value regardless of what side you're coming from. And what's even nicer is this is like the same distance to the right as this point was to the left. So because of the symmetry, they have the same y value. So I'm going to say that this limit is also 6 over the square root of 2. And again, it doesn't matter if you're coming from the right side or if you're coming from the left side, it would also be 6 over the square root of 2. So we can actually say the limit of this function at that point when x is approaching 5 pi over 4. I shouldn't say at that point. It's never at the point, it's just approaching it. But the limit exists. It's the same value from the left and the right, so we would say it's 6 over the square root of 2. The last question is just asking us to think backwards because it's telling us the limit doesn't exist. It just wants to know like what value could the graph be approaching where the limit doesn't exist. So we just have to find a place on the graph where one side is approaching positive infinity, the other side is approaching negative infinity, and that'll be it. There's lots of different answers we could write. Like over here, the graph is approaching positive infinity from the left and negative infinity from the right, so negative pi over 2 is one possible answer. But just to be like overly thorough about this, we could find another value. Like here, the graph is approaching negative infinity from the left and positive infinity from the right, so we could say positive pi over 2 and also 3 pi over 2. Those are all values that we could answer this question with. So positive pi over 2 or 3 pi over 2. Any of these would be acceptable answers. And that's really all you need to know to get started with limits of trig functions.
Find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!